Okay, in this, so I'm going to start the create network between containers using networks in the Docker Katacoda. So let's start scenario here. Start scenario. So first, there will be five steps, and first thing is I'm going to create network. So first we have to first to create a network we have to use this command. So it's our predefined name. So and I'm going to connect to network. So I'm just going to run this command here. From here, from this command, just enter to network. So there will be network communication here. So exploring which we need to use those commands to do some kind of things. And first thing I will notice the Docker no longer assigns environment variable who updates the host file of container. So explore using the following commands, and you will notice it's no longer mentions to the container. So I'm just going to run this command at first. So you see the host name, and I'm just going to run the second command here. Yes. So you can see the host name, about IPs and other things here. So we start the way containers can communicate via an embedded DSN server. So the DNS server is assigned to all containers where IP equal to 700 and 11 and setting the resolve.config file. So to do that, I'm going to run this command here by clicking this and just run the command. So you can see the name server and the options and methods such as the so when containers attempt to access the other containers via a well-known name such as Redis, the DNS server will return the IP address of the correct container. So in this case, the fully qualified name of Redis will be the redis.backend slash dash network. So to do that, so I'm going to run this command here. So as I mentioned, I just run the command here, and you can see the pings and the byte that have been transferred, the breaks, time, sequence, such things. So we're going to go to the third step, which connect two containers. So first, we have to create a network in the same way. So I'm just going to run this command here, and then we will launch the web server again. So just run this command here. So this will be the web server. So it attached to the same network, and it will be able to communicate with our DC instance. So just going to start this here, and it's going. So just going to test it for this command, reading this command. So it has been generated after talking to Redis, and this is the IP count. So it's continuing it and utilize. So links are still supported when using a local network and provide the way to define and get last to the container name. So this will give the container an extra DNS entry name and way to be discovered. So when using links, the embedded DNS will guarantee that localized lookup results only on that container where the link is used. So to connect to the container with the lice, so I'm just going to click this command to run the command. So in here, as you can see, that I have run the command in here, and so when the containers attempt to access the service by the name DB, they will be given the IP addresses of our Redis container. So as you can see here, so to show that, I'm going to just click here to run the command. So we run dash dash net frontend network to alpine in dash slash c1 db. So From this command, you can see the ping and the data rates that have been passed in the server, like IP addresses, sequence, and times, packet that has been passed and transmitted, packet such as received, something like that. So then I'm going to continue to the next step. The fifth step. So from this command, I'm going to disconnect the container. So with our network created, we can use the CLI to explore the details. So the following command will list all the networks on our host. So from running this command, we can see the network which in our system, in the Docker and the names and the driver scope and the network ID. So this one is spec. So this command, so as you can see, this output. And then I want to following command to disconnect the Redis container from the front end network. So to do that, so I'm just running this command by pressing this. So the disconnect has been successful. And that's all for that scenario. And now moving to the scenario which is persisting data using volumes. Also in Docker. So this going to start scenario which has three steps. The first one is data volumes. So Docker has created design when containers are started. So data volumes allow you to map the host directory to a container for sharing data. This maps is bidirectional setting. It allows data stored on the host to be accessed from within the container. So it also means data saved by the process inside the container is searched on the host. So tasks. This some example will use Redis as a way to process data. So start a Redis container below and create data volume using the v parameter. So by this command, I'm just running that. And as you can see, the output. So just passing the next steps. So we can pipe the data into the Redis instance using the following commands. So just we check to the command. So as you can see, the data then transferred, waiting for the last reply. The last reply is it from the server, zero errors and one reply. So that command has been successfully lost, and I'm going to see the Redis files using this. So as you can see, there is append only.ao file. The same directory can be mounted to a second container. One usage is to have a Docker container performing backup operations in the data. So to do that, so I'm just going to run this command by here, clicking here. So now the backup, the Ubuntu LS append only.ao has been backup. So just going to the second step, which is shared volumes. So in this case, we are mapping our Redis containers volume to Ubuntu container. So the data directory only exists within our Redis container. However, because of volume from our Ubuntu container can access the data. So to do that, I'm just running this command. This data. So this allows us to access volumes from the other containers without having to be concerned how they are used on host. So okay, just need to run the command again. Just start this audio again. Try some these commands. Moving to the second part. Okay. Yes, so I'm moving to the Third step, which is counting volumes, give the container full read and write access to the directory. So you can specify on read on permission the directory by adding permissions to the mount. So like this command, just giving those with the binary flag. And that's all for the processor and for the persisting data using volumes.